Okay, so today we are talking about SIMs. Let me go ahead, share my screen. SIMs or SIEMs, however you want to pronounce them. And we're going to talk really just that high level, talk about analyzing security data before you guys actually play with a specific SIM solution. So what are we talking about? We're talking about what is a SIM from a high level. We're talking about how we collect security data and all kinds of data in general. Talk about how we normalize that data so that we're able to actually perform analysis and keep records. And we'll talk about the two major types of logs. These are just two major ones: event logs and syslog. Okay, so SIMs from a high level. Right, we have to kind of review logs from Friday. Right, and logs are really a critical part of security assurance. Right, it's not just I don't want you to think of logs as something that we do and look at after the fact for incident response. Like, we're not just waiting for something to happen and then going to like, okay, let's go check out the logs. We also need to be a little bit proactive. And so that requires regular review of logs, a process we'll call threat hunting or log hunting. And so to facilitate this process of looking through logs and being proactive, we use a SIM. This is a software/hardware solution to kind of centralize our logs, to clean them up, to make them indexable and searchable, and to, a lot of the nicer ones, we'll be able to build all kinds of cool dashboards and generate different kinds of reports. Okay, so what do we need to do with SIM? We need to log relevant events, and we need to filter out all the noise. You guys remember watching the videos over the weekend, that big monster that's growing with like all the machine data that's constantly being created because of all of the different devices that we keep adding to our networks, both hardware, real world ones, and virtual devices. Right, all of these things are creating more data, and we need some kind of solution to deal with this data, to make it actionable, to make it not just garbage. I think they had a good diagram of like how fast computing is changing, and we're able to keep up with that, but we're not able to keep up with how much data we're creating with all of the different devices, all of the different machine data. Okay, so as we're creating a SIM, right, we have to filter out the noise, and what does that also include? It includes making a scope of what we want to record. Right, we cannot record everything, I guess is what I'm trying to say here. So we have to establish what is important to listen to. It's kind of like how our brains work. Like, tons of information is constantly hitting our nervous system, and your brain has to work to filter out events and pay attention to certain things. And so that's kind of what we're building here with the SIM. We're building a brain, a central nervous system, to deal with all these loggings. Right, so we're going to develop use cases and define our threats. Right, this is like what we did a week ago. We're trying to define what are our threats and what are the behaviors of our threats, trying to imagine what they might be doing, so that we know what to look for inside of our logs, and perhaps even automate looking for those things. We do all this so we could plan incident response. So something goes wrong, right? An incident happens. We already have some kind of playbook. So, we'll know what to do when something goes wrong. They'll usually have some kind of ticketing system where, something goes wrong, you notice some kind of event, some kind of alert. We're going to tag some kind of ticket to it so that, you'll be able to follow what's happening as it gets analyzed. Maybe you have someone logging in, someone logs in with their VPN in Asia, which is fine. Maybe you're an international company and someone's on business. But, then you also find out their ID was used in a server building the same day, that's in the United States. And you're just like, well, that is certainly some kind of interesting security event. We should pay attention to it, right? Because only one of those things can be true. This guy is either in Asia or he's in this building, right? So, that's when you are going to go look into your logs, look into your SIM, try and determine what happened. And again, the process of actively looking through these logs for specific security events is called threat hunting. So let's say, you're looking for someone that's logged in for two places at the same time. whatever types of logs that you've decided you'll look for to be as evidence for that. If you are actively looking for those things, you are threat hunting. You are currently hunting to catch the bad guys in the act. Okay. Cool. So this is SIMs. This is why we use them at the highest level, right? I think I had said last week, I referenced Minority Report. Right? That's that idea here. We got these precogs. They're going to tell you all the different kinds of events, and you're able to like look through it. That's what I like to imagine it as, at least. So let's talk about some specific SIM solutions. Again, I try and make these 2 days of lecture as vendor agnostic as possible, because I don't want you to just have to think, oh, I got to learn Splunk. It's the only thing out there, because it's not. Okay, but of course the big one, the number one, the big guy out there is Splunk, right? They're market leading, and I do want to tell you that Splunk is not first and foremost a security solution, right? It's a big data solution. It was made, as a kind of analysis tool for big data. And the cool thing about Splunk is it can import all kinds of different machine data that you saw right over the weekend, kind of connects it via some kind of connector. They're pretty popular. Some of the big players, we could talk about some of the big players in it, but the biggest one I know offhand that uses Splunk is Domino's, the pizza place. So if you're looking to work at Domino's, you might want to learn Splunk. Cool. What's cool about Splunk is it's really good at processing different kinds of data sets. Has like an indexed search, so you can search through all of the data. It has its proprietary, what they call it, search processing language, or maybe they even call it Splunk processing language now, right? So you can make queries. It's kind of like Bash, if you remember, where you like have big data and you like filter down to filter down. You can make all kinds of different cool dashboards, all kinds of different cool reports to send things out, as you guys saw over the weekend and as you will see today and tomorrow. So that's Splunk. It's the one that we're going to actually play around a little bit with, but there's more, right? So other big one is ELK and Elastic Stack. This one's cool. It's free. It's open source. It does a lot of the same things Splunk does. You can make dashboards, all sorts of things like that. If you are targeting a particular company and you see that they use it, this is cool because, again, it's free and open source. So you get it installed on your own machine. There's ArcSight. This is another one that is another like log management SIM software. This niche for ArcSight is that it's specifically, their niche is for compliance reporting. So for like legislation like HIPAA, SOX, PCI DSS, those sort of things. If you're looking for a SIM solution that has like sort of an eye for compliance, possibly the SIM solution for you then. There's Exabeam. I'm not as familiar with this one. I know at least one graduate that uses it, and I know one of our instructors here for the part-time program is one of their security engineers. So he works on building some of the features there over at Exabeam. Again, another solution kind of like Splunk, does a lot of the same things. Aggregate your logs, search through your logs, build dashboards. There's QRadar. What do I know about QRadar? I actually don't know too much about QRadar. I think it's made by IBM. Alien Vault and OSSIM. This one's pretty big and out there as well. It is open source. You might also see it under AT&T. So it's like a big one for telecoms, but this is made also by AT&T. So if you see Alien Vault, OSSIM, or AT&T SIM solution, it's like the same thing. The big thing about this that I've seen is that they're very good at integrating open source tools. So you can like pump your snort and like OpenVAS data right into this Splunk solution. So if you are in an organization that potentially has a bunch of open source tools that's already being used, maybe this is the same solution for you then. Right. So my point here is that there's a bunch of these different tools. They all work pretty similarly, right? They take in log data or machine data. They normalize it in some way, and we'll talk a little bit about that, and make it searchable for you. The nice features that they'll generally have is you can make into dashboards, you can generate reports, you can make some kind of alerts, right? The whole point is it makes your job as an analyst easier. Because as we saw on Friday, looking at all different kinds of logs from different kinds of places, it requires a lot of like mental energy, I guess is how I would describe it, right? You start looking at a log, you're like, okay, what am I even looking at here? How do we parse this together, right? We need something that can sit on top of all of these logs and make our lives easier, so we can focus our brain power on doing the analysis instead of reading, like, how do I read this log, or what exactly is this saying? The other thing I want to mention here, since we're talking about vendor things, vendor specific things, is when you are in flight and you're looking for work, as you are getting and preparing yourself for interviews, I think a good technique would be to look and see which of these SIMs the company you're targeting uses. There's pretty easy ways to do it. You could either kind of like look online. They might have that stuff public. If it's a large company, I know each of these SIEM companies, if you look online, you could see lists of their customers. And that way you look like someone who is prepared, eager for the job, and like technically capable as well. Right. So, if you find out you're going to be working for, like, the big example I'll give you is Splunk and Domino's, just because I specifically know someone that works there now, is, use that tool then, right? Specifically use their tool that they want to use. And a few of these, again, are open source, so you can get them installed on your own home network too. Of the ones that are not open source, I think they all do also offer free trial versions, or like, non-developer versions or something like that you can take a look at on your own. Okay, cool. So how do we collect data? So the first thing we need to know when we're collecting data for security is that data needs to be current, right? The intelligence that we collect, it loses its usefulness over time, right? You find someone's breaking in, you want to know that they're breaking in right now. You don't want to know that they were breaking in months ago. I mean, I guess that's useful after the fact, but it's more useful, intelligence is more useful when it's current. Okay, so SIEMs should be configured so that they're automatically collecting your data. Right? They should be automatically configured so all logs are getting like piped into one syslog server, right, where the SIEM can kind of access that and process them and make them indexable, make them searchable for you as the analyst. So in order to use a SIEM, we're going to require some setup first, right? We're going to require some kind of setup. So, when we're thinking about we're automatically collecting, remember, we can't just collect everything. It would be too much. So we have to ask ourselves, what information do we want to collect? What is going to be important? Right? Because all of that data, it's got to be stored. We have to process it. We have to normalize it in order to use it for analysis. And doing all of those things has a cost associated with it, whether that be time, whether that be physical resources. Right? We have to make that trade-off between physical resources, time, and everything else, and being able to catch our threats. We have to be careful for false negatives and false positives. Right? These are things we definitely have to talk about as we're discussing risk. And we need to develop use case for different behaviors. So, when I say use case, I'm talking about like specific conditions that should be reported. So like who, what, where, when sort of things, right? I'm talking what data sources and what indicators we're collecting from. I'm talking like what query strings you even searched for. I'm talking like what actions should occur when an event happens, right? Like what's some playbook? Okay, this happened. What are we supposed to do next? And I'm talking, we have to answer these questions. When did an event start and end, right? We need that information. We need who was involved, right? Specific people or accounts. We need what details, like what happened. Did someone run a program that has malware? Okay, that's the what then. Where, what did it happen on a particular host? Did it happen on a particular server file system? Did it happen on a particular network? And then, the second where, like, did it happen inside our network, or is this something that happened outside of our network? We have to think about all of these different behaviors and things that can happen, be creative and think about all these things before we can even start to think, what do we need to collect to see these things happening? my point is there's a lot of work that has to go into and a lot of creativity. That's why we do all that threat hunting and threat analysis before we even start collecting this data, or at least that's why we started to talk about that before we started talking about collecting data. Any questions before I go on here on security data collection?
I'm not sure I'm 100% on the develop a use case for behaviors, just in the sense that then you went on to list a bunch of stuff which seemed like it was all over the place. So is that just kind of a generic way of saying what?
Yeah, this is a generic way of saying you see something happening, you already know what to do about it. So you see some kind of behavior in your sim, there's already a playbook for what should happen. You guys as analysts are not going to be in a position where you get some kind of alert and you don't know what to do next. There should be some kind of playbook where this alert pops up, you know what to do next. You know what to look for, and you know what to do next depending on what you see. Cool. Good question. Okay. So, all right, so we're collecting our data, right? We've decided what do we need to collect to find our threats. And now we need to normalize that data, right? So again, security data is coming from everywhere. It's coming from hardware, it's coming from software, it's coming from virtual devices. Right? We've decided we're going to collect firewall data. We're going to collect, event logs. We're going to collect traffic flow. Maybe we'll have a couple packet sniffers so we could have PCAPs, and we're going to send all of that data to our syslog server, to our SIM. But again, right, this is all coming from different areas. So, right, all of these different sources are going to have different file formats. They're going to have different ways of storing their data, and we need to put it into a standardized form. Right? And this is what a SIM is going to help us do. So, right, the question we have then is like, what actually is normalization? And so here's our clear answer, right? It's whatever process we're going to use to take data from its, initial log format, and whatever we have to do to turn it into a different form to make it easy so that we can scan it and do analysis. Okay, so anything we have to do that. Someone has to write code for us to do that. So where does SIM data come from? There's three main sources. We're going to be getting our data from. There's agent-based. And agent-based is when you have some kind of service that's installed on a host that's going to log information, filter information, and like aggregate the information and normalize it right there on the host, and then send it to a SIM server. So it's like something that already lives on the machine. It's collecting logs. It's going to format it. And then once it's all nice and formatted, it's going to package it and send it over to our SIM server. And when it's on the SIM server, that's where you'll do analysis. That's where it'll be there for longer term storage. Okay, so that's agent-based SIM data. Otherwise, we could have like some kind of listener. This is going to be something that essentially listens for log data and just pushes it to the SIM server, maybe via syslog, right? Maybe using that protocol or using SNMP protocol. So it's not going to do any filtering or normalizing data. It's just going to send it raw to the SIM server. And then lastly, we have what we'll describe as sensors. And these will be, any kind of network tap or, anything that collects traffic flow, right? Any of those things, they'll send their data over to the SIM as well. Right? So all three of these are going to send their SIM data to a centralized place. And then that's where we'll normalize it, or at least the agent-based one will do it on its own machine, but everything else will be normalized inside the SIM server. Okay, so what's normalization? We have a problem here, right? What are the different file formats that we have here? What kind of different formats do we already know of?
CSV.
Yeah, what else?
XML.
Mm-hmm.
PCAP.
Yep.
JSON.
Yep, I got a whole bunch. I think we've gotten all of them that are on my list so far, but I think I have a couple more. You've seen some.
Also .log.
.log, yeah. So we got
docx. Sorry.
docx, yeah. So we have a whole bunch of different formats. We got a whole bunch of proprietary formats, like even like binary encoded proprietary formats, comma separate, right? Someone listed that. We have tab separated, we have space separated, XML, JSON, text based, right? Dot logs. We have syslog, SNMP, right? All of these different formats for data. That's a problem if we're trying to find, trying to be able to aggregate it in one place and make it quickly searchable for us. We can already see that that's definitely an issue, right? So all of this raw data needs to be parsed and normalized into a format that we can use, right? We see that that's the issue. This is what SIMs are going to solve, right? So someone wrote software for us to parse and normalize it into a SIM, and this software will is generally called like a connector or a plugin. So yeah, your SIM, maybe Splunk, right? You want to collect data from a certain firewall. You'll have some plugin that'll connect the data from the firewall to the SIM. That someone solved this problem already for you. Which is another potential reason you might choose a SIM, right? Which SIM has the most plugins for the software I'm trying to collect data on? Again, so that's one thing you might be looking at. The other thing, right, that we need to consider when we are normalizing data, what's the other big problem here besides these different formats? It's a big problem with international companies, global companies.
Date time groups.
Yeah, man, time is super difficult to deal with, especially when all of these different data sources are producing different kinds of timestamps. They might be in different places in the world, right? We have to make sure that when we're normalizing all this, we're also accounting for what time we're using. Some kind of standardized way so that everyone knows what time we're talking about when some certain events happen, right? Because maybe that event where we were talking about someone who logged in at the same time in Asia and in the United States, maybe it was fine, but the timing was off. 12 hours off, or time zones were not set properly. Potential something to look for. The other thing I want to pay attention to as we're talking about normalizing data, I don't want to say this is really normalizing data, but it's something to also pay attention to. Logs have potentially, it's not the word, dangerous information in them if someone nefarious got access to those logs. Right? Like we don't necessarily want people to get access to our logs, which means if we're taking logs and we're saving them somewhere, or we're taking logs and we're sending them from somewhere, right? We have this data in transit or data in rest. We should also be considering CIA. Specifically, we should be considering confidentiality. So if you take a look at the syslog protocol, the more advanced one, the more recent one, you have it uses TLS to encrypt the data as it sends the logs through. So something to be aware of and pay attention to as you're setting up your SIM system, right? Yes, all of normalizing the data is incredibly important to make it useful to us, but we also have to secure that data, right? Secure it as we're sending it to our SIM server, secure it as it is data at rest and we're holding on to it. Cool. Questions on normalization? Okay. So we'll finish here with events log and syslog, again, at high level. So can anyone describe what they think events logs are?
It's an incident of data being transferred in one way or another, depending upon what parameters you put it on. Like, so in Splunk, it would have been anything from like a GET request to somebody attempting to log in to a post request to like there's data, data the end, I guess.
Okay, I guess let me help then. Who creates event logs? Right, when I'm talking about event logs, in my context, I guess.
I think the OS, the system creates event logs.
Boom, MD's got it. right? So when I say event logs for this context, we're going to talk about logs that are created by the OS on any kind of client server system, right? Record users, record how they interact with them, record when people log in, log off, right? That sort of stuff created by your OS. Those are going to be event logs. Windows has their own event logs, right? Mac has their event logs. Linux has its own event log system. Just want you to be somewhat familiar with that. So when I'm talking about things created by an OS, what to look for in them, they'll generally have this information, right? Name, details of the errors, an ID, unique ID, what created the event, like what process, and some kind of description. The other thing I want to talk about is syslog. Syslog, right? We've already learned a little bit about it. We now know it's UDP port 514, right? Over the TCP/IP protocol. I had said to you that just recently that it uses, or at least the newer versions use TLS to encrypt the traffic, right? We're sending logs. We want to make sure that our logs are encrypted so no one else can read them. They also use hashing for authentication. So we are able to tell who, we're able to like sign the logs. So really syslog, it's a protocol for enabling different appliances and software to transmit the logs to a central server. I will say that out there, when people talk about syslog, just so that you're not confused, people generally are talking about three different things, all related, but three different things. They're either talking about the protocol. So syslog, it's an actual protocol, right? UDP 514. They're talking about the server itself, right? The server that's collecting all of this stuff. They might call that the syslog server. And they might also be talking about the logs themselves as syslogs. I agree with you that that's a little bit confusing and not super clear, but this is my experience of when people say syslog, they mean one of these three things. So be aware of that. They mean either the protocol itself, they mean the server that's collecting all of the logs, and sometimes they're talking about syslogs themselves, the logs themselves. Okay, cool. So in summary, right? What are SIMs? They're our single place for doing our log collection and our log analysis, right? They sit above all of the logs so that we have our cool system to like search through time and piece together things. One thing that's important that they do is normalizing that data. So make it easy to search, but also make it easy to search by time so that we can correlate different events and be able to kind of build a whole system of when things actually happened. And the last thing I want to say is Splunk is just one SIM solution, right? It's not the only game out there. When you are looking for work, absolutely find out what is the solution that the job you're targeting uses and get that installed. Try it out for a couple days, and then you can talk about it when you go to sit in for an interview. You say, oh yeah, I really, saw that you guys are using Exabeam. So, I tried out the free demo of it. It was kind of cool or something like that, right? That is, that's my big tip for interviewing and when we're talking about SIMs. Okay. Let me stop share. And let's talk about what we're going to be doing for today.